Focus today takes a look at quadratic functions in word problems to get that real-life application, as well as writing quadratics when we're given just the zeros. Our first problem is a baseball player hits a ball towards the outfield. The height of the ball noted by h in feet is modeled by h of t equal to negative 16t squared plus 22t plus 3, where t is the time in seconds. And remember, if you want, you can replace t with x and h of t with y, if that is what you so choose to do. Our first question is asking what the maximum height the ball will reach. Let's think about this in terms of a graph. So we have here a graph that marks the height as the x-axis or the y-axis and the t as the x-axis. The plus 3 on the end of our quadratic shows that we have a y-intercept of 3, which means that the ball starts 3 feet off the ground. And then while this isn't perfectly accurate, we get the basic idea that the ball gets hit in an upside down parabola for the simple fact that it's a negative 16t squared. The maximum height the ball reaches, which is right here, is marked by our vertex, remembering that this is our y-coordinate. So if we look back up at the problem, the maximum height the ball will reach, remember this is going to be your y value, so the first thing we actually have to do is we need to find our axis of symmetry, so that opposite of b over 2a. This, for this particular problem, it would be negative 22 because our 22 is positive to start, or divided by 2 times negative 16. That's negative 22 over negative 32, which if we divide those out to get a decimal value, this is 0.6875. Now to put some context to that, this actually answers the second part of our problem of how long it will take the ball to reach its maximum height, because when we're trying to find our vertex, we look at this part here being our t, or how much time it takes to reach the horizontal aspect of this vertex point. And so this 0.6875 is representing 0.6875 seconds that it takes the ball to reach that maximum height. The second part, then, we need to substitute into the equation our maximum height, or our maximum time, our time that right for the maximum height. So we're going to take our 0.6875, so we got negative 16 times 0.6875 squared plus 22 times 0.6875 plus 3. And you get approximately 17.8 feet. So I'm going to put in here an equals 17.8 feet. So going back now, just as a reminder, how long the ball will take, this is going to be the axis of symmetry, which is what we found. Now the third part says, if no one catches the ball, how long will the ball stay in the air before hitting the ground? What this is looking at is we want to know what is the value of this point right here when it hits the ground. In other words, what is that zero value? We need to factor our equation. So we have there the negative 16t squared plus 22t plus 3. Can't factor out any common factors, which means I need to use the AC method. So I take my 3 times negative 16, so I need a number that multiplies to negative 48, because negative 16 times 3 is negative 48, and adds to 22. So if we do this, I think of 24 times -2. And 24 plus -2, it does in fact give me 22. So I know that that means that I can split that middle term, and that will mean I have -16 t squared plus 24t minus 2t plus 3. And so then I can factor by grouping. So I have my first group, my second group, I'll make it a plus and negative and group it. I see here with 16t squared plus 24t, I can factor out an 8t. So I have 8t, and that leaves me with 2t plus, or sorry, -2t plus 3. And then I can factor out a 1, and I still have -2t plus 3. And I could have factored out a -8t if I wanted to, but I did not have to. That means that my binomials are 8t plus 1 and -2t plus 3. If I set these both equal to 0, I have 8t plus 1 equal to 0. I subtract 1, I divide by 8, I get t equals -1/8. And if I do the other one, I get -2t plus 3 equal to 0. Subtract 3, and I get -3 divided by -2. I get t equals 1.5. And so I look at this, -1/8 is going to be in my graph back here. I'm looking for this one, which means I'm looking at this one, which would be 1.5 seconds as far as how long it would take for that ball to hit the ground.